Topological Polar Surface Area Introduction from NCBI website, link in the description below. Polar surface area, PSA, has been a widely used molecular descriptor in the study of drug transport properties such as intestinal absorption and blood-brain barrier, BBB, penetration. It is the sum of the contributions of the molecular, usually van der Waals, surface area of polar atoms such as oxygen, nitrogen, and their attached hydrogens. Calculation of PSA is complicated by the need to decide on and then calculate accurately the appropriate 3D molecular geometry or ensemble of geometries for each molecule being studied. In order to overcome this trouble, Ertl developed a very fast additive fragment method of calculating PSA, especially for rapid virtual bioavailability screening of a very large collection of molecules. Since the first report of this topological polar surface area, TPSA, it has become extremely popular in medicinal chemistry for virtual screening and for predicting ADME properties, including blood-brain barrier crossing tendency. Recently, Ertl reviewed the use of polar surface area in medicinal chemistry research. Since its publication, the main use of TPSA in medicinal chemistry has been for barrier crossing, ADME predictions, the original concern of Ertl. There have been very few reports on the use of TPSA as a descriptor for Hansch 2D QSAR, despite its great potential to encapsulate conveniently key aspects of a ligand's molecule's relative propensity for polar interactions with a specific target. Hansch 2D QSAR is an effective way to study drug receptor interactions, especially when the target structure is unknown. The published reports to date of use of TPSA in Hansch 2D QSAR models of specific inhibition of receptors have been limited to studies of HERG potassium channel inhibition and selective COX-2 inhibition. Some multiple linear regression analysis, MLRA, for QSPR studies have appeared which make use of TPSA as a descriptor of blood-brain barrier crossing ability, aqueous solubility, and toxicity. The few other QSAR studies which make use of TPSA do not use Hansch 2D QSAR. In previous MLRA models employing TPSA, all of which used the unscaled TPSA, the coefficient C for TPSA in the reported models have an absolute value of 0.01 less than C less than 0.05 and was positive for COX-2 inhibition and toxicity, and negative for HERG channel inhibition and BBB crossing.